This video goes over tree diagrams, which is a visual way of describing situations where you have more than one event occurring. So in our first example, we've got a coin being tossed 4 times. So we've got 4 separate events that are occurring. What we're looking for is the probability of there being 2 heads and 2 tails. So I'm going to start with my first event, which is flipping a coin. When I flip a coin, I could get tails or I could get heads. I'm going to flip a coin a second time. I could get tails or I could get heads. And if I got heads the first time, I could get tails or heads the second time. My third event, same thing, tails or heads, tails or heads, tails or heads, tails or heads. And then I'm flipping a coin 4 times. So I have 1 more part to draw of my tree diagram, but my options are the same. Tails or heads, tails or heads, tails or heads, going all the way down. Tails or heads, and tails or heads. And then to list all of my possibilities, what I'm going to do is follow along the branches of the tree to get all of my pathways. So my first option that I can have is tails, tails, tails. My second option would be tails, tails, heads, tails, tails. So I'll just use a different color here. I'll use green. So I could go then tails, tails, heads, and then I could go to tails. Let's try and keep them all in the same color here. Heads and then tails again. Or I could go down this other branch. Tails, tails, heads, head. Now I'm going to do the version where I flip a heads on my second. So I still am going down this top path by here, but then I'm going to choose heads next, tails, and then tails. So tails, head, tail, tail. And then I could have tails, heads, tails, heads. Choosing to get a head on my third try, I would get tails, heads, heads, tails, tails, heads, heads, heads. Moving on to my lower branch now. So now I'm going to flip a head first, tails second, and I'm following this upper branch here. I'm not going to write in yellow because that's too hard to see. We've got heads, tails, 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 heads, tails, tails, heads. Moving down to the lower branch, we've got heads, tails, heads, tails, heads, tails, heads, heads. Finally, my very last branch, heads, heads, tail, tail, head, head, tail, head. My last 2 possibilities are 3 heads in a row and a tail at the end, and finally 4 heads in a row. Now you can see how this is not practical for too many events, because you are going to end up with a lot of situations, right? So sometimes you use a computer generated probability tree diagram, or you would use a different method. This is just like the sample space diagram. We're listing all our possible outcomes. The only difference is that here we're looking at where there is more than one event, really with the same 2 possibilities. So we are looking for the probability of there being 2 heads and 2 tails. So I'm just going to put it down here. So I could write it like this: 2 heads and 2 tails. Doesn't really matter what order it is. I do need to know how many possibilities I have. So I'm going to count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So I know that coin has been tossed. There are 16 possible outcomes. And so I can figure that out by looking at the number of ways that I would get 2 heads and 2 tails. So going through, Let's see, I will use yellow this time because I'm highlighting. So I'm looking for 2 tails and 2 heads. So I've got 1, 2, 3. This one should actually be a head at the end. And then I'm going to keep going, 2 tails, 2 heads. There's another one here. 2 tails, 2 heads. 2 tails, 2 heads, and I get 1, 2, 3, 4, 5, 6 out of 16. That's just counting all my possibilities, which is then going to reduce to 3 over 8. I could also figure this out by finding the probability of one pathway and multiplying by the number of similar pathways. This works really well because my probability for each event is 1 out of 2. So multiplying along any single pathway of your tree diagram will give you the probability of those events occurring. Okay, so everything is a half when we're flipping a coin. So my other approach, we'll write it out again, is I know that I'm going to look at, let's see, we'll use the purple again. So to get 2 heads and 2 tails, I'll look at this pathway right here. I would have a half times a half times a half times a half. And I've got 1, 2, 3, 4, 5, 6 ways to do that. So 1/2 times 1/2 times 1/2 times 1/2 times 6 different pathways that are going to give me the outcome I want gives me the same 6 out of 16 or 3 out of 8. That would be my probability for getting 2 heads and 2 tails, which I found using a tree diagram. So let's take a look at our second example. And here we've got the probability that George, who's a good forward in soccer, the probability that he scores a goal is 0.3. So let's say probability of the goal equals 0.3. George is going to take 3 shots. So there's your clue that you might want to use a tree diagram. You've got more than one event. And you're going to assume that the success with each shot is independent from the previous shot. So no nerves if he misses on the first one, and no overconfidence if he scores on the first one. So we're going to find the probability that George has 2 goals, has no goals, and has at least 1 goal. So if we know the probability that George gets a goal is 0.3, the probability that he doesn't get a goal is 0.7, and I'm going to use that feature to set up my tree diagram. So the first shot George takes, it could go in or it could not go in. The probability that it goes in is 0.3. The probability that it doesn't go in is 0.7. My second shot, I've got the same 2 options. Goes in, doesn't go in. And then same thing on the other option for my first branch. And then on my third shot, George has that same option. So I'm going to go ahead and fill in my tree diagram. Yeah. And each time I have the same probabilities here. So I've got 0.3, 0.7, 0.3, 0.7, 3.7, 3.7, 3.7, 3.7. Okay, so I want to find the probability that George gets 2 goals. So let's start with A right here. So the probability that George gets 2 goals. So what I want to do is I'm going to take a look along my pathway here, and I'm going to mark these ones in red. So George can get a goal on his first and second one, and then not a goal on his third one. So that's one pathway. Or he could go goal, no goal, goal. Finally, his third option would be no goal, goal, and then goal. for the probability that he gets exactly 2 goals. So in order to look at that, I'm going to take the probability along the pathway and then multiply by the number of similar pathways. So the probability that he gets a goal is 0.3 times 0.3 times 0.7, which is the no goal. And I know from my tree diagram that there are 3 possible ways to do that. Multiplying those together is going to give me the probability that he gets 2 goals, which is 0.189. Now, if he has no goals, I'm actually going to do the same thing, except I'm only looking for the pathway where he gets no goals. So that would be no goal on the first one, no goal on the second one, poor George, and no goal on the third one. So to write that out, my probability that he gets 0 goals would be 0.7 times 0.7 times 0.7. There's only one pathway that makes that possible. So I can multiply those together, which would give me 0.43. Now my final option is the probability that George gets at least 1 goal. At least 1 goal. So this, I could count up all the pathways. I can also use a shortcut and say that the probability that he gets at least 1 goal would be 1 minus the probability that he gets no goals. I've already calculated the probability that he gets no goals. So I would do 1 minus 0.343. And I would get about, let's see, 0.657 for his probability that he gets at least 1 goal. If you really wanted to check, I can use the same method. So for at least 1 goal, I just have different pathways to add in. So if I write sort of over here, so at least 1 goal is either what I wrote, 1 minus the probability of no goals, or I need to add up all the pathways where he gets 1 goal, where he gets 2 goals, and where he gets 3 goals. Doing that approach will also give me the same answer. It's not quite as efficient because I'm going to have to calculate 2 things that I haven't already calculated before. So those are the first 2 examples for the tree diagrams. These are known as tree diagrams without replacement because the probability remains consistent from event to event.